Okay, so let's go ahead and prove the triple angle identity for cosine today. All right, so the claim, or the triple angle identity of cosine, is that the cosine of 3 alpha is equal to 4 cosine cubed alpha, okay, minus 3 cosine alpha. Okay, let's go ahead and prove this statement today. Okay, so we've got cosine of 3 alpha, starting with this. And I know right off the bat that I can think about this as the cosine of alpha plus 2 alpha. Okay, good. Now I am going to be using the cosine, the cosine of an expansion formula, which I've proven in a past video. I will go ahead and provide it right here. Cosine of A plus B is equal to cosine A cosine B minus sine A sine B. Okay, again, this has been proven in a previous video if you so desire to see that. Okay. And so we can say certainly, let's maybe move this down here. We can say certainly this is going to be cosine of alpha, cosine of 2 alpha, okay, minus sine of alpha, sine of 2 alpha. Just like that, using this formula. Okay. Now, good. We've already proven in a past video as well that the cosine of 2 alpha is equal to cosine squared alpha minus sine squared alpha. Okay, so we are going to be using this identity here. We're also going to be using the sine of a double angle, which we've proven in the same past video. Okay, so that's going to be 2 sine alpha cosine alpha. Let's get that in the box there. Okay, good. So let's go ahead and expand using these two formulas. So we're going to have the cosine of alpha, and then here cosine squared alpha minus sine squared alpha. Okay, and then minus sine alpha, and then of course here 2 sine alpha cosine alpha. Okay. Okay, looks good. Let's go ahead and expand. Okay, let's expand. So we're going to have cosine cubed alpha, okay, minus sine squared alpha cosine alpha, okay, minus 2 sine squared alpha cosine alpha. Okay, very good. And just checking to make sure that that is correct. It indeed is. Okay. Okay. Well, looks like this term's not going to be problematic. We do want to result in a 4 cosine cubed alpha term, so this helps us get there. We only want a single cosine alpha term, so let's make sure we convert these sine squared factors into terms of cosine squared. And we're going to, of course, use, in order to do that, the Pythagorean identity, sine squared alpha plus cosine squared alpha is equal to 1. Let's get a box around that. Okay. And of course, we have a proof available of this in a past video, so feel free to access that if you're interested in seeing that proof. Okay, good. So we've got cosine cubed alpha. Okay, good. Minus, okay, well, sine squared alpha is 1 minus cosine squared alpha. So let's get that in there. Times cosine alpha, of course. Okay, minus 2, and then again, sine squared alpha is 1 minus cosine squared alpha. and then of course cosine alpha there. Okay, and that looks good. Just quickly checking over that, making sure we don't have any careless errors. Very good. Now let's go ahead and expand completely. So we're going to have cosine cubed alpha, okay, minus cosine alpha, okay, minus negative, so plus cosine cubed alpha, okay, minus 2 cosine alpha, okay, minus minus, so plus 2 cosine cubed alpha, okay, and we're done. Cosine cubed alpha plus cosine cubed alpha plus 2 cosine cubed alpha is going to give us 4 cosine cubed alpha. And then negative cosine alpha minus 2 cosine alpha is going to give us minus 3 cosine alpha. There we go. All right. Hopefully you found this video to be instructional. And we always appreciate your questions, comments, and concerns. It's important that we understand not only how math works, but also why it works. That's why we have to prove these statements. We can't just assume that they're true. We have to see for ourselves. We always appreciate recommendations for future content. We love proven statements around here for math and physics. If there's something we've missed, please bring it to our attention and we will put it on our list of priorities of things to prove. Have a great rest of your day, and we will see you in the next video.